Fine. Welcome to the class. So in this class we will be covering epicycloid, and you can see this is the statement right here. So epicycloid is the path traced by a circle. So this is the circle which is rolling without slip on another circle. So this is one circle on which this circle here is rolling without slip. Fine. So on this circle which is rolling, we have a point P. We have a point P, and that point P will be traveling on a path, and that path, which is this curve, this we are calling it as epicycloid. So that curve we are calling it as epicycloid. Now, how to get this using physical objects? I am just planning a video on that, a separate video. I will try to create it sometime later. In this session, we will just see how to draft this particular curve in AutoCAD. Okay, so first of all, let me just explain to you a little theory about that. So I'll just okay, so let me start by telling you about this. So as I told, there is a circle. Fine. So there is a circular path. There is a circular path, and on this circular path we have another circle which is rolling. So this is rolling circle. Rolling circle. Fine. And this is called the base circle. This is called the base circle. So base circle is the path, fine, and rolling circle will roll on it without slipping. And in this situation, the curve that we get, this is called epicycloid. This is called as the epicycloid. There's one more possibility, and that possibility is that the circle is rolling inside. The circle is rolling inside of this. So if it is rolling inside, once again we will get another curve. Fine. So this is the curve that we get, and this curve here, what do we call it? We call it as hypocycloid. So we call it as hypocycloid. So in both these cases, we'll have to find the angle. We will have to find the angle. Fine. So this angle, let us say it is theta. So we have a formula for this angle. We need a formula for finding the value of theta. So let us see how to get that formula first. Okay, so let me begin. So to begin with, you can see that I'm telling it is rolling. It is rolling without slip. So which means length of rolling circle. Fine. So what is the length of this rolling circle? So we have a special name for that. What do we call it? We call it as circumference. So the circumference of the rolling circle should be equal to the length of this arc. Fine. So from this point to this point, so length of this arc. Fine. So length of this arc. So that should be equal to the circumference of the circle. So let me write on length of arc. Okay, so we should know the formula for both these. So what is the formula for circumference of a circle? So I'll just write the radius of the smaller circle as small r, radius of the larger circle I'll write as capital R. So what is the length of the rolling circle? That is the circumference. It will be 2 pi into small r. And then the length of the arc. So what is the length of the arc? Formula for length of the arc: if this angle is theta here, the length of the arc formula will be theta divided by 360 into the total length. So total length of means the total circumference. So what is the total circumference of the larger circle? That will be 2 pi into capital R. So now we can cancel these two values. So 2 pi, they are on both sides. They will cancel out, and we will be left with small r equals theta by 360 into capital R. So we want the formula for theta. So send all the other entities to the other side. So we get theta, small r by capital R into 360. Small r by capital R into 360. So this is the formula that we get, and this formula we will use to calculate the angle to be drawn first. Fine. In the case of a cycloid, we just needed the length of the circle, so we just used this formula and we took the horizontal length as this. But here, because this is rolling on a circle, instead of length we need a angle, and the angle formula is coming with this formula. Fine. So let's see what is our question, and let us try to find the angle for that. Fine. So before that, let me just start with the template in a fresh file. Fine. So I've started the template file, and what is the first thing we have to do? As soon as we start the template, we have to save it. Fine. So this one we are doing for Epicycloid. So I'll just save it, and now I can start drawing it. So okay, so I'll just take this question, paste it here. Fine. So according to this question, we have to find the value of theta. Fine. So what are the things we need in this? We need small r, we need capital R. Once both these values are known, we can find the value of theta. So look at the question and tell me what is the value of small r. It's telling radius, the circle of diameter 60 is rolling without slip. So the rolling circle diameter is 60 mm. Rolling circle diameter is 60 mm. So diameter is 60 mm. So what will be the radius? Radius is d by 2. So half of 60, that is 30 mm. Then coming to the okay, very good. So next, capital R. Capital R is the radius of the path. Fine. So you can see here radius of the path, that is 90 mm radius. So radius is directly given to us. We just write 90 mm here. Okay. So now let us go on to find the angle theta. So that is small r, which is 30, divided by capital R, that is 90, multiplied with 360 degrees. So simplifying this, we get 120 degrees. Fine. So this is the angle we need to draw. This is the angle we need to draw. So let us begin. Okay. So first line I can take at whatever angle I want. Fine. So there is no hard and fast rule. You have to take at a particular angle itself. But if you want your diagram to be perfect, what you can do is you can take half of this on both sides. Fine. Right. Sorry. Actually, we have to take 180 minus 120 by 2. Fine. So this angle is 120. So we need to find this angle so that both these angles are same. Fine. So this is the formula for that particular thing. So what do we get? We get 60 by 2, that is 30. Fine. So if you want your diagram to be symmetric on both the sides, you can take it at 30 degrees. So there is no hard and fast rule. Fine. Just remember, this is just so that your diagram looks neat and cool. Fine. So this side 30 degrees, I will take a length, some random length I can take. Fine. So this is the first line. So after you have drawn the first line, you have to take the path of the circle. So for the path, center we have to take exactly here. Now you can see the point is not visible, and that's because O snap setting is off. So turn on the O snap setting and please ensure that end point is ticked here. So from the end point, we'll have to draw a radius of 90 mm. So what did you do? I typed C, enter, then clicked on this point, and then I have entered 90, enter. Next, we need the rolling circle. So to get the rolling circle, I will draw a circle somewhere on this. And what is the diameter of that? You know the diameter is 60. We can also just feed 30 as the radius. So if we feed 30 as radius, automatically it will take the diameter as 60, sorry. So now we have to move this so that the contact point comes here, comes and touches the main circle. So select this, take the move command. You can take it from here, or you can just type M, enter. Then take it from the intersection point. Once again, if the intersection point is not visible, go to OSNAP settings. So take intersection point, click here. So now we can see the center of the circle is on the line and it is touching our path. Fine. Next, we have to draw this angle. So what is the angle for which we have to draw? It is 20 degrees. Fine. So 20 degrees. So next we have to draw 20 degrees from here. So what formula will we use? We will use rotate formula. Before giving rotate formula, just rotate command, just select the line, then press arrow, enter, then click on this point here, and then right click, choose copy, and now we can feed the angle. Now angle we need in clockwise direction, so please make sure you feed negative angle, so minus 120. Fine. So you can rewind back the video and check out if you are not understanding any step of it. You have to follow it exactly as I have mentioned. Next, select both these lines, press TR for trim, enter, click on this circle. So we need only this part. Fine, we need only this part. That's it. So next I have to take offset. So O, enter, and in the offset there are three options. You can see through, erase, layer. So we have to choose option through. Right click, choose option through, click on the circle, click on the center point. So this is the path of center point of the circle. This is the path of center point of the circle. Now we will have to take a number of points on this circle. We have to take a number of points on this circle. So how many number we will take? 12 exactly. We will take 12 number of divisions on this arc. So give the command div, enter, click on the path of center, then press 12, enter. Once again you can see the points are placed but they are not visible. So we have to change the value of p type, choose a symbol which you like, set this to absolute and make this as 2 mm. Click OK. So now you can see the points are visible. Next we have to divide the circle also into same number of parts. So here we took 12 parts, same we have to take on the circle. So to do that, first we have to draw another line. I'll just change the color so that you can see that. From this point we have to start and up to the intersection point. So we have drawn a red line here, you can see that is overlapping this previous line. No problem. So we can select this red line, then give array command. For dividing the circle, please don't use the divide command, because divide command starts randomly at some point and makes equal number of divisions. We don't want that to happen. We want those divisions to start exactly at the point of contact, and hence we have to draw the line and then select the line, give the array command, choose polar option, and then click on the center. You can see by default it will create 6 number of copies, but we don't want 6 copies. How many copies do we want? We want 12 copies. So press 12 and enter, and you can see the circle also gets divided into 12 number of divisions. Fine. So once you have done that, press escape. This line also I will change the color of this so that we don't get confused later on when we are pointing the marks. Okay, so this we have to do. Next we have to take offset again, and once again we have to right click and choose through, then click on the arc and click on the end point of this. Fine. Click on the arc, click on the end point, click on the arc on the end point, click on the arc, end point. So this you should continue doing till you come up to the topmost point. Fine. So if you want, you can extend this as well. To extend, select the circle, press EX, enter, and click on all the arcs. Okay, so this arcs we have to get. In case of cycloid, if you remember, instead of these arcs we had drawn straight lines, and the line passing through the center of the circle was overlapping with the line passing through the horizontal line. But in this case these two arcs are different. Fine. So here we have to be extra careful when we are marking the path of the curve. Okay, so let us begin. Before going that, I can just name all these points as well. So I'll just copy paste this text at all these points. Okay, so this is where the path starts. 1 2 3 4 5 6 7 8 9 10 11 and the last, that is 12. Okay, so this is how the naming should appear. Fine. Now the center points also need to be named. So first point here has to be C1. Fine. So the first point has to be C1. I'll just copy this and paste it once. So 2 3 4, okay, 3 4 5 6 7 8 9 10 11 12. So only the main points I will just mark it. So this is 1 2 3 4 5 6, sorry, this is 6, this is 7 8 9, and last one is 12. Yes, any doubt? Okay, so this is the center and these are the points on the circle. Now we have to take a reference of this circle and go on marking the points on the path of the curve. Okay, so select this circle, click on the center point. Now you can see the circle is moving with me. The circle is now moving with me. So keep this circle on the center C1. Keep the circle on the center C1. Now we have to mark the intersection of this circle and this arc. This arc is passing through the first point, right? So it is passing through first point, and the circle is having center at C1. So intersection of these two we have to mark. So I will give the command PO for point. I will place a point here. So you can see the red point has been placed here. Now the circle needs to be moved to the next center, and a point needs to be placed at the next intersection, that is the intersection of this arc and this circle. Continue doing the same. So third point, keep a point at the next intersection. So be careful, don't put the point at the intersection of these two arcs. This red arc is for the center, not for the third point. Fine. So when you keep the circle at the C3 point, we have to mark the intersection of the arc passing through 3, not from the center. Fine. If you misread this, the entire curve will go wrong. Fine. So be careful at this particular point. Next, all the points are very simple. So keep moving the circle, keep placing the point. Keep moving the circle, keep placing the point. Keep moving the circle, keep moving the circle, keep putting the point. Fine. So now if you have observed carefully, at every arc there were 2 intersection points. At every point there were 2 intersection points. Fine. So one was on the left and another was at the right. So till half we have used the left intersection point of the circle. Fine. So here also you can see the previous point, we have used the left intersection. The right intersection we left it. Fine. So till half we have to use the left intersection point, and after the half we have to use the right intersection point. So now we should not mark this point, we should mark the right point. Fine. So continue doing the same. So this is the point. Next, for C9, the ninth arc, okay, the ninth arc is this one. So we have to mark intersection of this and this, and which one? The right side of it, not the left side. Okay. So next, move it again. So when we move here, this is C10. So 10th arc is this one and not the center. Fine, not the center, mind it please. This one we have to mark, and again we have to mark the right side of it. Move it again to the next one, point, mark it, and the last one, C12, will exactly come and touch our path. It will come and touch our path. Once all the points are marked, move the center back to its initial point. Fine. So now we have marked all these points. Fine. So now the naming of these points we can do using this point. So I'm using control paste, copy paste. So this is the first point. This is the first point, 2, 3. So because the space is less, I'll just mark the important points. 4, 5, 6. So I'll just mark 6. This is 6th one. 7, 8, 9. Let me mark the 9th one. And 10, 11, 12. So last point is coming here. Fine. So now we have to draw a smooth line passing through all these points. Fine. So what is the command we have to use? We have to use the spline command, SPL enter. Start at the intersection of the circle and the path, then passing through P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12. Once you have done pointing all of them, press enter. Fine. After you pressed enter, select this, keep your cursor on the last point, choose the tangent direction. Fine. Now tangent direction can be anything. You can see when we change the tangent direction, it is slightly changing like that. So tangent direction should be this line. Fine. It should be this line. So same goes for the starting point. Keep your cursor on that. Once the options come, choose tangent direction, and you can see you can modify the tangent, modify it to the starting line, this one. So this will create our arc. Fine. Our epicycloid. Fine. So hope you have understood this, and of course the video will be uploaded. You can watch this, and for others, even I'll be uploading some other videos, as I said, how to physically draw this using circle and all. So if you want updates to that as well, subscribe to the channel, and there will be a bell icon. When you subscribe, click on the bell icon, you will get subscribed, and as soon as I upload any video to the channel, you will get notification of the same. Okay, so that's it for this. In the next one we will take up hypocycloid.